You ever stop and think about how weird AI is? It can crush a grandmaster at chess, but it struggles with stuff a toddler gets, like don't drop a glass, it'll break. So, what gives? Well, we're going to get into that because the answer is pointing towards a huge shift in AI. We're talking about something called world models. Essentially, we're trying to teach AI to build its own intuition, a gut feeling for how the world actually works.
All right, so here's how we're going to break it all down. First, we'll tackle AI's big common sense problem head on. Then, we'll check out the blueprint some of the smartest people in the field have for actually solving it. After that, we get to the fun stuff. We'll see it in action with a world model that's learning to drive a car. From there, we'll zoom out and see how this same tech could, simulate everything. And we'll wrap up by looking at what this all means for the bigger quest for true machine intelligence.
Okay, so let's dig into that first piece, the fundamental challenge. With all this insane computing power, why do AIs still feel so clumsy, so clueless about the obvious stuff? I mean, think about this. A teenager, right? They can learn to drive a car in maybe 20 hours. But an AI, it needs to simulate millions of trials. Why the huge difference? Well, it's because that teenager isn't starting from zero. They have a whole lifetime of just existing. They know that if you throw a ball, it falls. They have this built-in intuitive physics. Today's AI, it has none of that. It's like learning to drive by crashing a million virtual cars over and over. It's not just inefficient. You could never do that safely in the real world. And this is where AI pioneer Jan LeCun comes in. He basically says the missing piece is something he calls a world model. It's not just about seeing patterns. It's about having an internal, predictive understanding of the rules of the game. And in this case, the game is reality itself.
This is why current AI can be so brittle. That's the perfect word for it. When it sees something that wasn't in its massive training dataset, it can just completely fall apart in weird ways. You or I, when we're driving, we can reason, that road looks slick, I should probably slow down for that turn or I might skid. We can predict that without ever having skidded before. And that's exactly the kind of predictive power we're trying to bake into these machines.
So let's just nail down this definition because it's super important. A world model is basically a simulator running inside the AI's head. Before it does anything, it can run a bunch of quick, tiny simulations. Okay, what happens if I turn left? What if I hit the brakes? This lets it plan ahead and pick the action that's, safest and gets the job done.
Okay, so a world model is the goal. Sounds great, but how in the world do you actually build one? Well, LeCun didn't just point out the problem. He actually laid out a blueprint, an architecture for how these intelligent systems could be put together.
And his idea is actually pretty elegant. It breaks down intelligence into these different parts that all work together. First, you've got the perception module. That's pretty simple. It's just the eyes and ears, sensing what's happening right now. Then comes our star player, the world model, which takes that info and predicts all the possible futures. Next up is the cost module. Think of this as the AI's conscience, or its goal system. It looks at those possible futures and judges them. Crashing the car? Bad. Arriving safely? Good. And finally, you have the actor, which proposes the actual moves, like turn the wheel, that the cost module thinks will lead to those good outcomes.
So you see how it all works together, right? It's this constant loop of seeing, predicting, judging, and then acting. The system isn't just following a simple script. It's actively imagining different futures and then picking the path that looks best. This is the difference between a simple reflex and real deliberate thought.
But come on, that leads to the multi-billion-dollar question, doesn't it? That all sounds great on paper, but how do you actually get a machine to imagine the future of something as chaotic and unpredictable as a busy city street? That is a massive challenge. So let's look at how people are actually trying to pull it off. And this brings us to a real-world example. Let's talk about a system called Gaia 1. It's a model from a company called Wave, and it's one of the first really big, practical attempts to build a world model, specifically for the crazy world of self-driving cars. So Gaia 1's approach is really clever. It starts by taking in a ton of data, video from the car, text notes about the scene, and what the human driver is actually doing. But here's the genius part. Instead of trying to predict every single pixel in the next frame of video, which is insanely complicated, it first squishes each frame down into a simpler code, a sequence of visual tokens. Then it uses a transformer model, the same kind of tech behind ChatGPT, to just predict the next token in the sequence. It basically turns a messy video problem into a much cleaner language problem. And this comparison right here makes it all make sense. We're all getting used to how large language models work, right? They're just amazing at predicting the next word in a sentence. Well, Gaia 1 uses that exact same core idea.
But instead of predicting words, it's predicting the next chunk of visual code that describes what's about to happen on the road.
And you can see what that looks like right here. On the left, you've got the raw video from the car. On the right, that's the tokenized version the AI actually sees. It's an abstraction, a simplification. By doing this, the AI doesn't get lost in the weeds trying to render every single leaf on a tree. Instead, it can focus on what really matters, learning the physics and the dynamics of how those blocks that represent cars and roads and people move and interact over time. Now, to make this work, you need an absolutely massive amount of computing power. Gaia 1 has 9 billion parameters. That puts it right up there with some of the big language models you've heard of. And it learned its common sense about driving by watching almost 5,000 hours of real driving video. It just watched and learned the patterns of the road all on its own.
Okay, Gaia 1 is incredible, but it's hyper-focused on one thing, driving. So what happens when you take this powerful idea of next token prediction and you point it at, well, everything?
And this is where things get really mind-bending, because the basic technique is totally general. It doesn't matter if your tokens represent words in a book, cars on a highway, or waves on a beach. If you have a powerful enough model and enough data, it can learn the underlying rules of how those things interact and predict what's going to happen next.
And that brings us right to models like OpenAI's Sora. You see the difference here? Gaia 1 is a super specialized world model for driving. Sora, on the other hand, is a hint of what a general-purpose reality simulator could look like. It wasn't just trained on traffic cams, it was trained on a massive, diverse library of videos, and that's why it can generate these jaw-droppingly realistic video simulations from almost any text prompt you can dream up.
And the potential applications for this are just staggering. I mean, we're talking about way more than just making cool videos with Sora or self-driving cars with Gaia 1. Think about training robots in a perfect simulation so they can learn without breaking expensive hardware, or modeling incredibly complex systems like climate change or drug discovery, or creating virtual reality worlds that are indistinguishable from the real thing. This isn't just one application, it's a foundational technology.
So let's wrap this up by taking a step back and looking at the big picture. Where is all of this actually taking us? Well, it points to a really fundamental shift in how we think about and build intelligent machines.
I mean, just look at this timeline. It's insane. In 2022, this was mostly a theoretical paper from Jan LeCun. A year later, we get Gaia 1, a powerful real-world model for driving. A year after that, Sora comes out and just blows everyone's minds with its general simulation capabilities. The pace is incredible. It really points to a future where we stop hand-coding rules for AI and instead let them build their own understanding of the world just by watching it.
And that, right there, is the single most important takeaway. For decades, we've tried to build smart systems using explicit, handwritten rules. You know, if you see a red light, then stop. World models are a total paradigm shift. The AI isn't just told to stop, it learns why you stop, because it has observed the consequences of not stopping in thousands of hours of data. It builds a much deeper, more flexible kind of intelligence. And that leaves us with this really deep philosophical question to chew on. If a machine gets so good that it can predict our world with near-perfect accuracy, does it actually understand the world? Or is it just the most sophisticated pattern-matching engine ever created? Honestly, that line is getting blurrier and blurrier every single day.
This is for entertainment purposes only.